Drivetrain and Axles. Hello folks, welcome to today's lesson on drivetrain and axles, essential components of any vehicle's mechanical system. In this session, we will explore the various drivetrain components and their functions, different types of axles based on vehicle drive configurations, and basic repair techniques. Our goal is to provide a comprehensive understanding that will benefit those working in automotive environments. Drivetrain components and functions. The drivetrain, also known as the powertrain, encompasses all the components required to transfer the engine's power to the wheels of the vehicle. Here are the key components and their roles. Engine. This is the power source of the vehicle. It converts fuel into mechanical force. Transmission. It adjusts the engine's output to the desired speed and torque by selecting appropriate gear ratios. Differential. This component allows the wheels to rotate at different speeds, which is particularly necessary when navigating turns. Drive shaft. Delivers power from the transmission to the differential. Axles. These are the shafts around which wheels rotate. They support the weight of the vehicle and transmit torque from the differential to the wheels. Together, these elements work seamlessly to ensure the vehicle moves efficiently while maintaining control and stability. Axle types: front-wheel drive, rear-wheel drive, all-wheel drive. Vehicles can be categorized based on which wheels are powered by the engine. Each configuration has its advantages and challenges. Front-wheel drive FWD. In FWD systems, the engine powers the front wheels. This setup is common in many modern cars due to several benefits. Advantages: improved traction in wet or slippery conditions because the engine's weight is over the driving wheels. Also, FWD vehicles generally have more cabin space as they do not need a rear drive shaft. Challenges: can lead to understeer during aggressive turning. The weight distribution is often heavier in the front, which might affect handling. Rear-wheel drive RWD. Here, the engine's power is transmitted to the rear wheels. RWD is preferred in performance and heavy-duty vehicles due to its characteristic handling dynamics. Advantages: better balance and handling, especially during acceleration since the weight shifts to the rear. Ideal for high-performance driving. Challenges: less traction on slippery surfaces due to uneven weight distribution with less pressure on the driven wheels. All-wheel drive AWD. AWD systems distribute power to both front and rear wheels. They are often used in crossovers and SUVs for enhanced versatility. Advantages: superior traction on all surfaces, improving safety and capability in adverse weather and rough terrain. Automatically adjusts to provide power where it's most needed. Challenges: increased complexity and weight, which can reduce fuel efficiency. Repair and maintenance costs can be higher. Basic drivetrain and axle repair techniques. Regular maintenance and timely repairs are crucial for keeping the drivetrain and axles in optimal condition. Here are some basic techniques to consider. Visual inspection. Regularly check for visible signs of wear or damage, such as leaks, cracks, or rust. Pay attention to unusual sounds or vibrations, which may indicate mechanical issues. Lubrication. Ensure that all moving parts, especially joints and bearings, are well lubricated. This reduces friction, prevents overheating, and extends the lifespan of the components. Checking and maintaining fluid levels. Transmission and differential fluids should be checked and replaced according to the manufacturer's recommendations. Low or dirty fluids can lead to significant wear and performance issues. Alignment and balancing. Misalignment or imbalanced wheels can cause uneven wear and strain on the drivetrain. Regularly check alignment and balance to ensure smooth operation and prolonged tire life. Replacing worn-out components. Immediate replacement of worn-out or damaged parts, preventing further damage. Always use quality parts that meet OEM specifications. By understanding the roles of each drivetrain component and recognizing the symptoms of wear, you can ensure better performance and extend the lifespan of both the vehicle and its individual parts. Summary executive. Here's a summary of drivetrain and axles. Drivetrain components: 1. Engine produces power and torque. 2. Transmission transfers power from engine to drivetrain. 3. Drive shaft connects transmission to differential. 4. Differential transfers power to wheels while allowing speed differences. 5. Axles transfers power from differential to wheels. Axle types: 1. Live axle, a solid axle that rotates with the wheels. 2. Dead axle, a non-rotating axle that supports the wheels. 3. Independent suspension axle, allows wheels to move independently. Drivetrain functions: 1. Power transfer, transfers power from engine to wheels. 2. Torque multiplication, increases torque output to wheels. 3. Speed reduction, reduces speed while increasing torque output. 4. Traction, maintains contact between wheels and road surface. Common drivetrain issues: 1. Vibration, imbalance or misalignment of driveshaft or axles. 2. Noise, worn or damaged components such as bearings or gears. 3. Leaks, fluid leaks from transmission, differential, or axle seals. 4. Wear on axle bearings, differential gears, or transmission components, maintenance and repair. 1. Regular inspections, check driveshaft, axles, and differential for signs of wear or damage. 2. Fluid changes, regularly change transmission, differential, and axle fluids. 3. Balancing and alignment, balance driveshaft and align axles to prevent vibration. For component replacement, replace worn or damaged components to maintain drivetrain performance. Here's a summary of drivetrain components and functions. Drivetrain components: 1. Engine produces power and torque. 2. Transmission transfers power from engine to drivetrain, adjusting speed and torque. 3. Drive shaft connects transmission to differential, transferring power. 4. Differential transfers power to wheels, allowing speed differences. 5. Axles transfer power from differential to wheels. 6. Universal joints connect driveshaft to transmission and differential, allowing flexibility. 7. Constant velocity CV joints connect axles to wheels, maintaining constant velocity. Drivetrain functions: 1. Power transfer transfers power from engine to wheels. 2. Torque multiplication increases torque output to wheels. 3. Speed reduction reduces speed while increasing torque output. 4. Traction maintains contact between wheels and road surface. 5. Flexibility allows for movement and flexibility in the drivetrain. 6. Stability maintains vehicle stability and control. Key considerations: 1. Efficiency, drivetrain components should minimize power loss. 2. Reliability, components should withstand stress and wear. 3. Maintenance, regular maintenance is crucial for drivetrain longevity. 4. Performance, drivetrain components should work together to optimize vehicle performance. Here's a summary of front-wheel drive FWD. Overview. Front-wheel drive FWD is a vehicle drivetrain configuration where the engine's power is transmitted to the front wheels, propelling the vehicle forward. Key components: 1. Transverse engine. The engine is mounted transversely, perpendicular to the direction of travel. 2. Transmission. The transmission is usually integrated with the engine, forming a transaxle. 3. Drive axles. The drive axles are connected to the front wheels, transmitting power and torque. 4. Hub bearings. The hub bearings support the front wheels and allow for smooth rotation. Characteristics: 1. Improved traction. FWD vehicles tend to have better traction and stability, especially on slippery or uneven surfaces. 2. Compact design. FWD vehicles often have a more compact design, allowing for smaller engine compartments and more interior space. 3. Lighter weight. FWD vehicles typically weigh less than rear-wheel drive RWD or all-wheel drive AWD vehicles, improving fuel efficiency. 4. Cost-effective. FWD vehicles are often less expensive to produce and maintain than RWD or AWD vehicles. Advantages. 1. Better fuel efficiency. FWD vehicles tend to have better fuel economy, especially in city driving. 2. Easier maintenance. FWD vehicles often have fewer components and are easier to maintain than RWD or AWD vehicles. 3. Improved safety. FWD vehicles tend to have better stability and control, reducing the risk of skidding or losing control. Disadvantages. 1. Torque steer. FWD vehicles can experience torque steer, where the vehicle pulls to one side under acceleration. 2. Limited towing capacity. FWD vehicles typically have limited towing capacity compared to RWD or AWD vehicles. 3. Less suitable for off-road. FWD vehicles are not ideal for off-road driving as they can struggle with traction and stability.
Here's a summary of all-wheel drive AWD. Overview. All-wheel drive AWD is a vehicle drivetrain configuration that transmits power to all four wheels, providing improved traction, stability, and control on various road surfaces. Key components. 1. Center differential. Splits power between front and rear axles. 2. Transfer case. Transfers power from transmission to center differential. 3. Front and rear differentials distribute power to individual wheels. 4. Drive axles connect differentials to wheels, transmitting power and torque. Characteristics. 1. Improved traction. AWD vehicles can handle slippery, uneven, or off-road surfaces with ease. 2. Enhanced stability. AWD vehicles tend to have better stability and control, especially during cornering or sudden maneuvers. 3. Increased control. AWD vehicles provide better control on various road surfaces, including snow, ice, and sand. 4. Reduced wheel spin. AWD vehicles minimize wheel spin, which can lead to loss of control. Types of AWD systems. 1. Full-time AWD. Power is constantly sent to all four wheels. 2. Part-time AWD. Power is sent to two wheels, with the option to send power to all four wheels when needed. 3. On-demand AWD. Power is sent to two wheels, with the option to send power to all four wheels when wheel slip is detected. Advantages. 1. Improved safety. AWD vehicles tend to have better stability and control, reducing the risk of accidents. 2. Enhanced performance. AWD vehicles can handle various road surfaces with ease, providing a smoother ride. 3. Increased towing capacity. AWD vehicles typically have higher towing capacities than two-wheel drive vehicles. 4. Better off-road capability. AWD vehicles are designed to handle off-road terrain, providing improved traction and control. Disadvantages. 1. Increased complexity. AWD systems are more complex than two-wheel drive systems, which can lead to higher maintenance costs. 2. Reduced fuel efficiency. AWD vehicles tend to have lower fuel efficiency than two-wheel drive vehicles, especially in city driving. 3. Higher cost. AWD vehicles are typically more expensive than two-wheel drive vehicles. 4. Added weight. AWD systems can add weight to the vehicle, which can affect handling and fuel efficiency. Thank you for attending this lesson on drivetrain and axles. Stay curious and proactive in applying this knowledge to your automotive projects. Regular care and understanding of these systems will greatly enhance the performance and reliability of any vehicle. See you in the next lesson. Happy learning, folks!